Actually, I need to talk about it because one of my Chinese friends I already mentioned him that he actually helped a lot. And other students of Changambiao students, they are actually very hardworking guys. So I actually took help from them. I am very thankful for them, and also Changambiao to help me a lot to do this project. So I really appreciate that. And then project application prospects and future innovative ideas that I want to share. Snake robot can be used in following areas. First of all, detection and rescue is very important part. Like the main basis of my design is the detection and rescue. We know it's very difficult to find people here inside. But how we can detect by the sensor that snake can enter and can give the signal that there's somebody is attacking you. So how the snake can enter a very complex process. So to do that, we need to think a lot, and it was really very challenging for us. So that's the aim, to detect the people under rock or construction. And next one is archaeological exploration. For archaeological exploration, we can send a snake under the water in sea level to see the archaeological situation, to know the better under the sea. We can do that. Then military reconnaissance we can do for it, for detecting the enemies. And then industrial application. For industrial application, I want to share that the places that we cannot enter, like a big whole pipe, the snake, we can take it over there to give the information. Then the innovative ideas, future innovative ideas that I want to share. You may ask that double helical gear snake robot is good, but what if we can think about that multi-helical gear, which will be more innovative, isn't it? So let's see this video. You can see this is a multi-helical motion that I am giving you the 3D animation. So my idea is in future, if I do that kind of innovative ideas that if I implement, that you can see there are 1, 2, okay. 1, 2, 3, 4. Like there are more than 4 or 5 connections here with the helical design. So if we can make this kind of design in future, so we can make the snake more sustainable, more precise. So it can enter any places, whatever it wants. It can actually make a very revolutionary work if we can make that. So it will be very challenging and not that very easy also. So that's my idea. I actually shared with you. With this, I'd like to conclude. Please ask me a question if I'm wrong and also correct.
Okay.
Yes.
Now I have a question to ask you. How do you assess the motion performance of your bionic snake?
Motion performance.
Yeah, motion performance.
Okay, for motion performance, we need to understand the first thing is versatile. Versatile locomotion is actually the main principle. First of all, for versatile locomotion, we need to consider 3 things. One is adaptive environment. Okay, adaptive environment. That means the environment needs to adapt the snake. The snake needs to adapt the environment, like the complex terrains, which is difficult challenge. Then 2, coordinating control system. Coordinating control system. How coordinating control, like the snake has a lot of body parts. So they need to coordinate each other, and the control system must be separate from each other, like our body. Our hand, body, leg are very coordinated with our main body system, our brain and everything. So coordinating control system is very important in a robot. Not only the snake robot, but also other robots. 3. The ability to give the feedback. Ability to give the feedback. Like snake must have the sense of giving the feedback. Like something is coming as an obstacle, he must consider it that this is an obstacle and we need to overcome over the obstacle. So that's the feedback idea, and it is really difficult to simulate that idea. So it's very challenging. Day by day it's developing. So for versatile locomotion, we need to add these three. We need to actually consider these three things. Then we can make a lot of progress, and snake can really move very well. That's all.
I have a question. So explain the difference between your design
And
and the
okay.
existing device.
Thank you, Lord, for asking that question. It's really very important question that I want to make for that. First of all, we need to think about my design is double helical. Double helical, but present world the Uncle Sam you have seen that design is single helical. See, not any helical, a single robot containing a lot of motors and body part. But mine is double helical. How double helical works, I will actually show you. Okay, when these two helical, one is left and another is right one. So when the force is giving here, is going this direction and is going that direction. So we can make a force direction with FA and FB, and the main force is coming out, which is resultant force FR. So this is the main idea for double helical drive. For single one, it is really difficult to control the left-right part and body lifting. It is really difficult because the Y connection system cannot be adapted with the single helical drive. So for that case, I need to make it double, so that like my two hand. So double means like we can balance both sides. So in that case, I think my design will be more effective in future. The second one is that present technology cannot ensure very complex terrains under the rock, but the helical drive, the double helical drive mechanism can easily ensure. So I can show you some. Show you the helical design. Yes. Right, for this design, oh, by the way, another thing I need to mention, this print is not that very good. I need to print from polycarbonate. I need to do from the polycarbonate print so that it can bend from each other. When it will bend, then it can easily change the position. So print must be polycarbonate material. Okay, with this I'd like to conclude my presentation here. Thank you guys for listening. Thanks to all.